Hey everyone, welcome back, and today we will be doing another lead code problem 590 N-ary tree post order traversal. An easy one. Given the root of an array tree, return the post order traversal of its node values. An array tree input serialization is represented in their level order traversal. Each group of children is separated by the null value. See the example. So we can see in the input we have a level order traversal given to us in which the null just separates the, you can say, two levels. Yes, two levels. So one is separated again, and then 3 to 4 again with the null value with the children of 3, 5 and 6. What we want to do is just return a post order traversal. So what is a post order traversal? In which there is a, the left comes first, then the parent node and left, right, and after at the after doing the left and the right, we are just going to add the parent node. So if this is a binary tree, we are going, not a binary tree, this does not have any left and right. A binary tree is a tree in which a node can have two, at the very maximum can have two child nodes, otherwise it can have less nodes. And if it does have more than two nodes, then it is not a binary tree, it is just an n-ary tree. Like in this, we are going to have an n-ary tree in which a node can have many nodes as a children. So we want to go to the very left. So we will be starting from the one, because one is the root. Go to the left, we will be seeing that 3 is the root. We will not be going to the parent root specifically. We will not going to append it to the output. We will go into the left of 3 and have 5. So 5 will be appended to the output. After that, we are going to the very right and appending 6 to the output. And after we are done with the left and right, we are going to append 3, the parent node, and 3 is appended. And now we'll be going back to the parent, but we do not want to add a parent yet, and we will be just adding the children of 1. And that's it. They do not have any children, so nothing will be appended. And after doing all of this, we can just append the parent node. So that's it. So first of all, checking if the root is valid. If the root is valid, but we want to if the root is not valid basically. So if it is valid, so we will append it to the stack and make another output list. So while there is something in the stack, what we want to do is just pop from the stack. So pop stack pop, and in the output we will just append its value. So the temp's value will be appended. So temp dot val. Okay, now what we want to do is for every children, so for every child in temp child, we just want to update our stack with it. So stack append with the child. Okay. After doing that, we can just return the output by just reversing it, and this should work. And this works. So we have a stack, we have an output. Okay, so at first we are going to have a root in our stack. If the root is valid, you can say, if the root is still root exists basically, so we'll be having output 1 because we popped from the stack. The while loop will start executing, and now we will append the children of 1 in the stack. So 3 to 4 will be added, and now we'll be popping again and appending to the stack. We will see that 4 does not have its own um, children, so this for loop will not be executed for 4. And same in the case of 2, because 2 does not have a children node, so it will also be popped and just appended to the output in the next iteration. And now we have 3 in the next iteration. 3 will be also popped and appended to our output, but 3 does have its own children. So for every children in the children of 3, so 3 does have its own children 5 and 6, we will be just popping the 6 in the next iteration and appending to the output. And after that, we can just see like 6 does not have a children, 5 does not have a children, 5 will be appending to the output. And after that, we can just reverse it and return output reverse. So 563, 563, 241, 241 is our output, and that's it.